Everybody, welcome to the UNCW STEM Lab channel. My name's Ashley and we're going to be going over some conversions that you'll see in Chemistry 101. The first question that we have gives you the conversion from H2so4 plus 2 LiOH to Li2so4 plus 2 H2O. The question says, what volume of 0.035 molar H2so4 solution is required to completely neutralize 250 milliliters of a 0.400 molar solution of LiOH? So the first thing that I would recommend do is get everything in the same units. So you know that a molar is, molar equals moles per liter. So we see right here that we have 250 milliliters. So to convert that, you would do 250 milliliters. Build your little railroad, build your little railroad tracks. And then you know that 10 to the third milliliters is equivalent to 1 liter. Or you can also just move your decimal places 3 places to the left and get 0.250 liters. So for questions like these, I always recommend that you start with what you're given. So we're given this 250 milliliter solution of 0.4 molar LiOH. So what you would do first is you would write down your 0.4 mole per liter of LiOH. Build your railroad tracks and go ahead and draw it all the way out. So you have that, and now you've just converted your milliliters to liters, so you're going to cancel out those units by doing 0.250 liters. And this is of LiOH. I'm not going to write it down every time just to save some room. And then that's it for that one. And that cancels out this unit and this unit. Moving on, we're doing, you're going to use stoichiometry. So this is liters, right here, this is liters of LiOH. And in our conversion up at the top is 2. So you have 2 mole of LiOH converted to 1 mole of H2so4. And that's coming from this coefficient up here at the top is a 1. Okay, so you know that you have 0.350 molar of H2so4. So on the bottom, this is moles right here, by the way. So you now have 0.350 moles for 1 liter, and both of these are H2so4. That cancels out this unit of moles of H2so4 and this unit moles H2so4. And then this right here cancels out moles of LiOH, canceled out with moles of LiOH. So now what we're with is just liters of our H2so4. And we can go ahead and do the math right here on this one and call it as our answer equals 0.143 liters of H2so4, or the same way that we did before where we moved the decimal 3 places to the left to go from milliliters to liters. We can also move that decimal place 3 points to the right to get 143 milliliters of H2so4. And that's your final answer. So just to go back over what we just did, you start with what you're given, you have 0.4 molar of LiOH, and you multiply that by the amount that you have. So it's the same as saying if you were measuring out a recipe for baking, like you had a cup of milk, saying that you have a liter of this level concentration of whatever that you're using. In this case, it's LiOH. It's the same gist. It's 250 milliliters of 0.4 molar stock solution of LiOH. So then you move forward, you do your stoichiometry mole-to-mole conversion. We had 1 mole H2so4 cancels with 2 mole of LiOH, leaving you with your liters of H2so4, and then just in final units, in milliliters, you move the decimal place 3 places to get 143 milliliters of H2so4. All right, moving on, we have a different equation. We have AgNO3 plus NaCl converts to AgCl plus NaNO3, and then we're given the formula weight for AgCl is 143 grams per mole. So question A is asking us, what is the mass of silver chloride, AgCl, or what mass of it can be produced from 0.21 liters of a 0.038 molar solution of nitrate? So this is another very similar question as to what we had before. We have liters, whoops, sorry about that. We have liters of a 0.038 molar solution. Like I was saying, you have a cup of milk, you have this amount of liters of this solution. Same gist. What mass of silver chloride can be produced from this amount of AgNO3? So first step, again, you start with what you have. So this is the answer to A. We have 0.21 liters of AgNO3 multiplied by, we're going to go ahead and draw all the way out our train tracks, multiplied by a 0.038 mole per 1 liter solution of AgNO3. This is also AgNO3. So right off the bat, this cancels with this. Keep going. Now we have moles of AgNO3. So for this one, all of our leading coefficients in our stoichiometry are 1. So we've got 1, 1, 1, and 1. So this step isn't necessary once you get the steps down pat, but it's really good to keep track of your units this way by just writing it out anyways, because you have 1 mole of AgCl, oops, that's a Cl, with 1 mole AgNO3. So now we know that mole of AgNO3 here cancels with this mole AgNO3. And this 1-to-1 ratio right here, that's just keeping track of your units more than anything. So now our units are in moles of AgCl. And we want our answer to be in grams. It's asking for the mass. So we're going to use that formula weight now that we have up at the top. You have, whoops, sorry, it keeps doing that. You have, oh my goodness, let's see. All right, 1 mole AgCl with your molecular formula, your formula weight, you have 143 grams of AgCl. So now we have mole AgCl cancels with mole AgCl, and we're left with our final units of grams of AgCl. When you multiply and divide all that out, you get 1.1 grams AgCl. And that is your final answer for this one. Now, for part B, going a step further, it says how many molecules of AgCl are produced. So we're going to backtrack a little bit. So we're going to start with what we just found. We have 1.1 grams of AgCl were produced. We know that. So backtracking using our moles once again, or our formula weight, we have 143 grams of AgCl is 1 mole of AgCl. So now we have our grams canceled back out, and we've gone backwards, essentially, back into the unit of moles. You should have learned in class that moles are like the center point, and they can basically convert you to grams, to molarity, to molecules. Moles are just a good spot to be at to convert from one unit to another. So now we're back in moles of AgCl, and we see right here that we're also given 1 mole equals 6.022 times 10 to the 23rd molecules. So we're just going to fill that in. 1 mole always, and that's not specific to AgCl or any sort of, compound. That's for all moles. 1 mole is 6.022 times 10 to the 23rd molecules always. So canceling out these grams, we're going to get back into moles of AgCl, but now we're just going to convert those moles into molecules. So this is our final step. Molecules. And just get my calculator out. So we've got 1.1 times 6.022 times 10 to the 23rd. That's multiplying all the way across the top and now dividing by everything on the bottom. So 143 times 1 on the bottom. You should get your final answer as 4.63 times 10 to the 21st molecules of AgCl. Alright guys, I really hope that helps. I hope that covers converting from moles, molarity, grams, molecules, anything that you'll probably see on your test. Good luck everybody.